Hey, I'm back again. I'm going to talk about a simple framework for planning your solution architecture for AI. So, let's go back in time. Since 2000, 52% of Fortune 500 companies have dropped down from the list. The average S&P 500 company lifespan has plummeted from 33 years in 1965 to under 20 years today, with forecasts suggesting it could shrink to just 12 years in the next year and a half. These numbers should concern every technology leader, but they also illuminate opportunity. The companies that endure share a common trait: they master the transition from promising experiments to production systems that deliver value. I am very fortunate to have had the trust and confidence of many organizations for their use cases involving data analytics and AI throughout my entire career. For a large telecom, I built deep learning pipelines using TensorFlow and PyTorch when transformer architectures were just emerging from 2017 Attention is All You Need paper. Along the way, there was a massive automatic speech recognition pipeline that kind of like we had to build for a large bank, leveraging end-to-end neural models that replace traditional HMM based systems. Those kind of pre 2016 stuff. Getting audio files transcribed all the way to topic detection still haunts me. Then there was a legal document analyzer built on BERT based models for highly regulated commercial confirmations, fine tuned for domain specific entity recognition and classification. More recently, in the land of GenAI, I have helped a pharmaceutical company stand up a RAG framework to find knowledge quickly, a fashion retailer experiment with vision language models to match styles with descriptions, and helped transit and safety leverage GenAI to parse dense safety reports to expedite infrastructure. So, throughout these technological cycles, I have learned many lessons and best practices that span across different industries. My goal in this video is to distill fundamental patterns on how to start and scale these efforts for Gen AI. Last year at Collision Toronto, these patterns crystallized into conversation that went beyond should we adopt AI to something more critical: how to architect for production success. So, contrary to the popular pattern of hey, let's bolt some Claude, building a solution architecture that not only can deliver a successful POC but can be productionized, that requires structured thinking. So, disclaimer, any sort of ramblings that I am providing here below is based on my experience, and they do not reflect the stance or recommendation of any organization that I may be affiliated with. So let's go to the four layer framework. Layer 1, where work happens, start with the fundamental decision: assistive or agentic. When exceptions rates exceed 20%, when regulatory stakes demand human oversight, when decisions require nuanced judgment, it's best to choose assistive. In this workflow, AI suggests and humans decide. However, if you have repeatable processes, clear success and acceptance criteria, and very easily measurable outcomes, go agentic. Let AI complete the task with batch level human review. If you can't describe task completion criteria in 2 sentences, you are building on unstable ground. Layer 2, what your AI must do. Production AI takes action. Can your system complete a full transaction without human manual work, human copy paste? Start with one workflow. Identify three core actions. Build tool calling capabilities for reading systems, writing to systems, calling external services, API calls, MCPs, and handling errors gracefully. Achieve 70% automation on routine cases before you expand scope. So anything less, and you have just built an expensive suggestion engine. Then the third layer, which brain to use? Model economics determine viability at scale. If API costs exceed 30% of human cost for the same task, your architecture will collapse under its own weight. It's a metric that we use. So, deploy smaller models for structured extraction. OCR, for example, is getting better every day at small levels of um, models, such as if you look at a DeepSeek OCR, or if you look at Marker by Vic Parachuri. So if the layout and data don't change, a smaller model can be faster, cheaper to run with many open source options. So just beware of the licensing of these models, but that's all. This allows you to reserve larger models for complex reasoning. Linear scaling kind of reveals that architecture thing. So use traditional ML for routine classification. So sometimes the old ways still work best. So calculate costs at 10x, 100x, 1000x the current volume that you have. And then, as I mentioned, like again, like linear scaling, this reveals an architecture that hasn't been optimized for production. All these factors critically impact key metrics like latency in milliseconds for these user requests, the cost for each request, and your intellectual property. So, if you take a permissive license model and fine tune it, it can give you control over changes to compared to commercial API models. And then the fourth layer of this four layer framework is how you maintain trust. Build your control plane before you need that control plane. So gather 100 plus real world examples including edge cases. Set the accuracy thresholds above 85% for these routine tasks. Demand consistency above 95% for identical outputs. Try to log every prompt, every response, and every user action. Full open telemetry. Establish confidence based routing rules, version tracking, audit trails, and kill switches. Walk through this scenario, and then you'll see that AI makes a costly mistake affecting a customer. Let's look at this, like how do you detect it? Do we trace it? Do we prevent recurrence? Vague answers generally reveal control plane gaps. So this is particularly critical in regulated industries. When an AI denies a claim or misprices a policy, the audit trail becomes legally essential. So you know about the four layer framework, and I've seen that after hundreds of implementations, clear patterns emerge, and organizations that successfully scale, they make these four critical architectural decisions before committing resources. These form layers that build upon each other, creating a foundation for enterprise AI. So yeah, that's why we have this four layer framework. And so let's think about the path forward from here. So these architectural decisions, they compound, and each layer builds on depends on the stability of those beneath it. So skip one and the entire structure just comes crashing down. So it becomes vulnerable to the kinds of failures that turn POCs, success stories, into production cautionary tales, famous last words kind of thing. So companies thriving despite compressed lifespans understand something very fundamental. Transformation succeeds through sound architecture, not algorithms. So clear workflow design, capable systems, sustainable economics, and mature control planes are key elements that determine who adapts to new technology with confidence and trust. These patterns become even clearer through my conversations that I had at Collision Toronto last year, where insurers, tech providers, they shared their journeys from experimental chatbots to production discussions for assistance. I'll be exploring these themes further at our next video, but for now, I have a question for you. So, where does your organization stand in this framework, and what's the next layer you need to strengthen? Comment down below. See you. Thank you.